Assalamu alaikum. Welcome to Study On. This is Samia Aziz, and you're here with me to learn the linear programming modeling from chapter number 2, Decision Theory and Analysis, or we call the subject name as Operations Research. Following are the lecture outline that we will learn today. First of all, we will start with understanding the question, which is a necessary step in any problem solving situation in this subject. Then we will create a data table from understanding the question. Third, we will make LP equation and the model. We will make the LP equations, linear programming equations, and we will create a model which will consist the equations as well as objective function that we will derive from the question. So altogether, when we will include both equation and objective function, a model will be created of a particular company. Then we will solve the equations and take out the feasible points. These feasible points are going to help us in finding out the feasible region. Then we will plot these feasible points on the graph and we will mark the feasible region, and we will put the, after doing this, taking out the feasible region, we will get some corner points. And what we will do is that we will take all the corner points, like corner point A, B, C, D, E, as many as the feasible region can have. All the corner points will be labeled as, for each corner, for example, might be a shape of pentagon. So for each corner we will label a point like A, B, C, and so on. So every corner point will be having certain value, right? Certain value of two coordinates, x and y, right? So with both x and y, we will put these two values into the objective function so that we can get the different objective function values. Like objective function, for suppose if it's corner point A, we can say that objective function which is represented by ZA. So we will put this time the value of XAYA. When we are talking about corner point B, we will be taking the coordinates of XB, XY, XB and YB. So we will be putting these value into objective function of Z, which is consisting values of B. Then might be like Z, ZC, ZD. Among all, we will choose the one which will be giving us a highest profit, and this will be suitable for the company. So that's coming into the next next topic to us. But for now, we are going to learn about what outlines we are going to cover. That this is the way that how objective function is going to be derived out, and in last we will, which is very mandatory, which is very important, because if you are solving and doing all the effort, and in last if you are not doing any analysis or suggestion, it's of no use. So you will be suggesting any business, any kind of business, that what you have derived out and what this actually means, and what this actually means, right? Along with the graph also, you will show the firm that what points he should make to make the business profitable, and what things he should avoid to save himself from the high costs. So here is the problem regarding a tailor who has a problem in his creation of the dresses. So we are being given with the valuable information, and now as being an operation research analyst, we have to drive out a suitable solution for the tailor. So let's first begin and read the problem. A tailor has following materials available. First thing first, in any operation research problem, you will be told, or what information you need to know is regarding the materials, that what materials there are that he is going to work with. First material he has is 16 meters of cotton, right? 11 square meters of silk, and 3 meter of wool. So he has basically 3 materials available for men creating dresses. And why we need to focus on the amount of materials and the type that he is going to use, because our solution is restricted to the amount of raw material he is available with. We are restricted to provide the best solution within these available materials. Okay, we cannot suggest him outside of the box. We have to suggest him in staying inside the box. So these are the materials availability to the teller. He can make out 2 products out of these materials, namely dress and suit. So he can always make two types of products, or you can say goods, that are dresses and suits. A dress, now there's a detail about that, how much of a dress needs materials. A dress requires the following: 2 square meters of cotton, right? And he has total 16 meters of cotton, out of which 2 square meter of cotton is used by a dress, 1 square meter of silk, and 1 square meter of wool. This is the information about making of dress. When we are talking about suit, it requires 1 square meter of cotton, 2 square meter of silk, and 3 square meter of wool. So this is information about suit. If the gross profit realized from the dress and suit is respectively N30 and 50, N30 and 50 is representing the profit, the daily profit that is being earned by production or creation of dress and suit. This is for the dress, this is for the suit. Formulate the above as a linear programming model. Why? Because we with this, what will happen, why we have to do that effort? Because why, when you solve this model of the linear programming model, what we will get an ideal solution, which will suggest us that how many units of dress to produce and how many units of suit to produce, which will be generating the maximum profit for the teller. So from the problem, we have made the table. Here it is. As you can see, in the first column we have put the materials in square per meter. Then there are the 2 products, product name, that whatever the product the company is making or the business is making. So here is a product name. This is the maximum material availability. So if we look at cotton, so dress requires 2 square per meter of cotton, and suit require 1 square per meter of cotton, and the maximum availability is 16. Whereas the dress requires 1 square per meter of silk, and suit requires 2 square per meter of silk, and the maximum availability is 11. And wool, dress requires 1 square per meter of wool, and suit requires 3 square per meter of wool, and maximum daily availability is 15. And all this information is available in the problem as I described here. So we have created the data table, and the profit per dress and per suit is given as 30 and 50. Right, now what are the steps in creating the LP model? Because now we have to move towards, after doing the 2 steps like understanding the question, creating the data table, now we will be making LP equations, and we will create a model. So to create the LP equation, first we have to identify the decision variables. Why we have to do that? Because if you do not represent them, identify them and represent them in algebraic or mathematical equation, mathematical symbols, so it will be difficult for us to recognize them, and we will not be able to put the values into the objective function. So we have to assign some variables to the values, right? So let x1 we say number of dresses to be made, let x2 is the number of suits to be made. So you can use any variable that you like x or y, might be a or b or anyone that you want to, right? So here I have taken x1, x2. So we have to represent them with the variables with the products that we have, dresses and suits. Step 2 is that we will identify the constraints or restrictions and we will represent them into LP equalities or inequalities. So it's not every time necessary that they are always equal to. They might be not equal to as well. So we have to identify that what kind of equation it's going to be. So okay, so from the problem we have to go back and to the data table, and data table tells you all. So this first will become your equation number 1. So how it will become equation number 1? So two dresses. So as I told you that for dresses we are using the symbol x1, and for suits we are using the symbol x2. So it becomes now easy. So here if I start making the equation, you will find it easy to understand that 2x1 and 1x2. So if I add them, and this needs to be always less than or equal to the maximum availability of cotton we have. So we will represent them less than and equal to 16, or say 16 is greater than the production that we are doing. So this is equation number 1. If we look at here, we have created the equation number 1 just like this: 2x1 plus x2 or 1x2 less than or equal to 16. If we look at the second equation here, that is available silk 1 and 2. So similarly, if I put x1 variable here and x2 here, so it will become 1x1 plus x2 and less than and equal to 11. And if you look here, that I have written the equation similarly: x1 plus 2x2 less than and equal to 11. The third equation is going to be of wool, and this is 1x1 plus 3x2 less than and equal to 15. So similarly, there is the equation that you are going to see, right? And in last, we have to make x1 x2 greater than or equal to 0. This is a constraint of non-negativity, right? Because if we are not going to put this restriction, so what will happen is that x1 and x2 can be 0, but if it happens, then all our hard work is going to be in vain, because we cannot suggest a company to produce 0 number of x1 or dresses or 0 number of suits, because company already wants to know that how many units to produce to create a profit or maximum profit. So 0 can never drive a profit. So that's why we put a non-negativity constraint on our variables. And then next is that we have to drive the objective function. Objective function is going to be dependent on the profit making. So this is the profit. 30 is the profit from the dress, and x1 is denoted by, we have to denote this for the dresses, and x2 for suits. So 50x2 represents the profit by suits, and this represents the profit by dresses. Now step number 4, we have to construct the model. In model, what you have to do is you have to just bring all the equations at one platform. So first you have to put the objective function that we just have derived here. This is the objective function, which is always subject to the restrictions. Restrictions are only from the raw material. So here all the equations we have put together: equation 1, 2, 3, and the last non-negativity equation. So this is the objective model. So next step goes to solution of the LP equations, and we have 3 equations. So equation number 1, 2x1 plus x2, and we have to convert it into the equation sign so that we can solve it, is equals to 16. So as we know that we don't have value of x1 and x2, so what we can do is that we will assume that x1 and x2, at one place we will assume the value of x1 is equals to 0, and in other instant we will assume the value of x2 is equals to 0. By doing this, we can obtain always, when we are doing x1 is equals to 0, we will be getting the value of x2, and then we will do x2 0, then we will be getting value of x1. So let's do it into the equation. So here we have first done x1 0, so putting x1 place 0, 2 into 0 becomes 0, plus x2 will be the same, is equals to 16. So x2 is equals to 16. This is the first value. By making x1 0, we got x2 is equals to 16. And the other place, when we are going to do x2 is equals to 0, let's see what the value of x2 is derived. So 2x1 plus x2, the same equation is there. 2x1 plus x2 is 0 this time, is equals to 16. 2x1 is equals to 16. So x1, 16 upon 2, 2 8 and 16, x1 is equals to 8. So this is the way how we have derived the value of both the coordinates when we didn't know initially that what the x1 and x2 value is, so we assumed it to be 0.